I think if our digital card game Chrono Cards was a card in our digital card game Chrono Cards, it would be something like an 8-cost event that says, "This is 1 fun. When summoned, create a copy in hand that is twice as fun." It has this crazy high-end potential. You want to keep playing more and more copies, new versions of Chrono Cards, so that each one is more fun than the last. But it takes a lot of resources to keep doing that. Figuring out how to develop this game has been like building a deck around this game plan. We have our units. There's Sam and Jasper, that's me, on development. Honor is working on artwork, and our mysterious intern Ben is also helping out. But in Chrono Cards, units are only half the story. A good deck also needs a healthy amount of events, and the order in which you play them matters as well. So let's look over our timeline so that you can get a quick look of what we've been up to in developing Chrono Cards. When we started out, we wanted to iterate really fast on the system, and making big, sweeping changes to the rules would just take too long if we had to do it all through code. So we opted to do quote-unquote paper prototyping through Tabletop Simulator, where we could just import all the data from a spreadsheet. We actually have a whole video about that process if you're interested in learning more, but for now, here's a quick recap of the system that we landed on. The main thing that sets Chrono Cards apart is that when you play a card, you play it onto the timeline, a board that is split into the past, present, and future. Once both players have played and paid for their cards for the turn, the cards that are currently in the present will trigger their abilities in order. After all the abilities have triggered, unit cards will engage in combat with the unit across from them. If any unit is unopposed, it deals damage directly to the enemy player instead. Finally, at the end of the turn, the timeline will advance by 1 slot, leaving the oldest present slot behind in the past, and bringing 1 slot from the future into the present. This means that by default, any card you play has a time limit on how many times it can activate before it gets left behind in the past. But it also means cards can move around on the board, move where the present actually is, target cards in the past and future and more, and that's where the real fun comes in. Paper prototyping helped us make a few important changes, like allowing you to play 1 each of a unit and an event at every slot. With the basic mechanics in place, we were confident enough to port our work into a digital prototype. But it was a little bit more difficult than just scanning it in. Sam and I sat down and we spent several days doing nothing but talking through the architecture of the game. It was a long and tedious process, but it set us up for success in the long run. Godot can handle a lot of the core UI interactions, and we can use plugins like Godot Steam to help us with some of the lower level networking. But the core logic was something we had to implement from scratch ourselves. And for something like a card game, where the text of any given card can completely change the rules, it gets complicated fast. So it was extra important that we get it right. Basically, the way the system works is whenever a card wants to do something, it turns to this piece of code called the action surface and says, "Hey, here's what I want to do and who I want to do it to." Then the action service goes and checks with each card one by one to go, "Hey, I'm about to do this thing. Do you want to change any of these details or even cancel the whole thing?" And assuming it doesn't get canceled, the action service does the thing. And then it goes to all the cards one by one again and asks, "Okay, I just did that for real. Do any of you guys want to do something about it?" And a card might say, "Oh yeah, whenever this thing happens, I do this. Action service, can you do this thing to this card?" At which point the action service starts over, asking every card if they want to modify or cancel the ability, so on and so forth. Broken down that way, it sounds simple. And that's the goal. The simpler it is, the easier it is for us to implement, and the more predictable it is for players to know what's going to happen on any given turn. The complexity comes in when these effects start chaining and interacting like crazy. But with a plan in place, we got to work developing the first playable prototype. To help us develop really quickly, Sam created a super handy tool that allowed us to import card data like cost, health, card text, etc. from a spreadsheet, meaning all we had to do was implement the actual card abilities. We also set up a unit testing framework called GD-Unit, which allows us to write automated tests that can tell us if a system or even a specific card is working the way that we expect it to. It basically sets up a specific scenario within a simulated version of our game and runs it super fast to check that everything is working as intended. So whenever we make a big new change, we don't have to guess whether anything is broken. We can just click a button and get a detailed report within a few seconds. With the help of these tools and lots of work, we finally had a playable prototype. It was a janky, ugly prototype with placeholder stock image art provided by
our mysterious intern, Ben.
But it works. And even though it was incomplete and not particularly good, as soon as it was playable, we got a small group of playtesters and put them on the game right away. A lot of the feedback was exactly what we expected. The UI could use some work, some of the card text was a little unclear, some cards weren't particularly balanced, etc. So if we already knew all this, why bother playtesting at all? Well, for one, it helps us confirm that we're actually right about these assumptions and helps us figure out what are actually the biggest sticking points for players. As developers, we have this giant to-do list of things that we need to get done in development. But by analyzing patterns in the player feedback, we can start to figure out which areas actually deserve the most immediate attention. Secondly, if there was something we were missing, we'd want to hear about it sooner rather than later. It's really kind of bad if you get all the way to the launch of your game and then figure out that it's just not fun. Luckily, our feedback seems to indicate that the core of the game is fun. It's just not done. At this point, we'd made some progress, so we wanted to make a video about what we'd been, let's move on to what's next. Thanks to the hard work of
our mysterious intern, Ben.
Our deck building menu is almost ready to go. Our next update will focus on shipping that feature along with a wider pool of cards so that players can experiment with making their own decks. We'll also start to introduce some of the card art that Honor has been working on as we narrow in on the game's style. From there, our focus will turn to primarily cleaning up the user experience of the game. We've started very small with our pool of playtesters to ensure that with every update we can get a mix of new and returning players. As development progresses, we'll even start to invite some of you viewers, so stay tuned for that. Now that the core systems have been built, individual features can be churned out way faster. That also means we'll have more to show off. So let us know, what are you most interested in? Do you want to hear more about the game design and card design aspects? Do you want to see more of the technical details of implementation? Do you want to see more art or even just gameplay? I've even thought about live streaming development. So if any of that is something that you're interested in, let us know in the comments. For now, the game has made a lot of progress, but there's still a lot to do. So we're going to get back to work on making the next prototype, and we'll be back with updates very soon. Thank you so much for watching, and goodbye for now.